All right. Good evening, guys. I hope we are fine. Um, last week, and last week, the last time we met, we ended on the standard number distribution. So we ended on how we will trace the standard number distribution on the Z table, and then how we will even use calculator to trace them. So using calculator was simple. So I've seen that 90% of all the people who did assignments was using calculator, which was very simple. And so I gave some little assignments. I gave this as an we solved this in class, and then I gave this one, and then this one as an assignment. And then let me see. Okay, I didn't give this one, so I gave up to this one as an assignment. All right, and then I'm glad that we were able to do it. The people who sent it to me was able to do, and those who were not even able to do it, I corrected them, and then they were on track. So let's solve just one question together, and then move on to today's topic. And mind you, today's topic, this topic, this topic was one of the topics I was battling with in quantity. Hey, it took me like 2 weeks consistent. Like I was consistently on this topic for 2 weeks before I understood it. Like looking at it will look very easy, but once the question drops, forget it. It's not easy. It's not easy. So kindly pay very, very keen attention to whatever we do today, because how I was able to understood it and now understand it is roughly. This is how I'm coming to teach you, and I'm hoping that you also understand it. So let's quickly go through this question. So please, can someone read it for us? Please, can someone read this question for us?
Okay. Can I read? Hello, can I read?
Yeah, please, you can read.
Okay. The Associate Dean of UGBS is going to purchase a new copy machine for the school. One model he is considering is the Xerox X10. The sales representative has told him that this model will make an average of 125,000 copies with a standard deviation of 40,000 copies before breaking down. A. What is the probability that the copier will make at least
Oh,
2,000
A.
copies?
You say
Come
A.
again?
You say A.
No, like point A.
Maybe not A. You see
Point A. What is the probability that the copier will make at least 200,000 copies before breaking down? Point B. What is the probability that the copier will make copies between 120,000 and 160,000? Assume number of copies is normally distributed.
distributed. All right. So according to this topic, according to this question, sorry, we can see that the mean here, which is the population mean here, is what 125,000, right? And then our standard deviation here is 40,000. And then now we are testing on the probability of 200,000. So this becomes what our sample. So this becomes our sample mean. So let's quickly go through this thing. I hope you can see my whiteboard.
Yeah.
All right. So according to this, our mean is equal to population is equal to 125 thousand, and then our standard deviation is equal to 40,000, right? And we are testing on the probability that at least, so meaning that anya will be, so we are testing on the probability, the first one, A, testing on the probability that X is less than or equal to 200,000. So quickly we put down our formula, which is the sample mean minus the population mean all over the standard deviation. So 200,000 minus 1 200,000 minus 125,000 all over 40,000. Right. So it moves on to 75,000 all over 40,000. Then we will be getting 1.88. It will be 1.7 something, but when you run it, you get 1.88. So getting 1.88, we trace this 1.88 on the Z table. So 1.8 on 0.08. So that's what you'll be tracing on the Z table. But using the calculator, as I always say, it is very simple and straightforward. So what we will do is we'll press mode and then choose 3, then we press AC. Then I will press shift and then 1. And then we choose 5, which is the distribution. And then we'll choose 1, which is P. Then we'll put in 1.88. We press equal to. It will give us 0.969695, which is approximately 0.97. So the probability that the machine will produce at least 200 copies
Kofi,
is, yeah,
Kofi,
yeah.
at least me, if it's greater than or equal to.
When at least and I
See, at least the probability that the copier will make at least 200,000 copies before breaking down.
Okay, yeah. But if at most it could be greater than or equal to.
Yeah.
Yeah, Rejoice, you said that when you got the 1 point, it was 1.875, right? So when you run it
Yeah.
up, then you get 1.88.
It is 2.8.
It is what?
Hello.
Yes.
1.88. Something. Just 1.88.
It was 1.88
Hello.
and plenty things. But you run it to this because this is what you can be tracing on the Z table.
Okay.
Do you get me?
Yes.
Do you get me? Okay.
Yes, I get you. But you see,
So
me,
it
I
was
didn't run
it
the
was
1.875.
always run it to
So
2 decimal
I
place. Because if you
had
don't run
okay.
it to 2 decimal place, you won't be able to. If in case of standard Z table, you won't be even able to trace it there. You understand?
Yes, I understand. But you see, initially I thought you said we should leave it to like 4 decimal.
And that's the final one here. The final probability, that's the one that you leave it in the 4 decimal. But if you are tracing on the Z table, you cannot trace more than 2 decimal places on the Z table.
Okay.
So now let's solve the B part, which was saying that the B part was saying what is the probability that the copier will print within 160,000 and then 120,000. So we already know the standard deviation, we already know the normal distance. So this will now be P probability of 120,000 and then wait.
Kofi,
Yeah.
the P no the symbol no equal to sign no go dey part o, so they say between. Are we there back?
Yeah. But
Yeah,
so
so
now it will still be the same. That's why they use something like that.
yeah. But now you see say maybe now looking at how it is, it go be like you dey start from exactly 120,000.
Yeah. I
Yeah.
understand. Thank you.
You're welcome.
So so what we are going to do, I might always say that we will bring this one to the first side, and then whatever we get for this on the Z table, we will come and then take this one out of it. So it will be 160,000 minus 120,000 all over the standard deviation, which is 40,000, and then minus, so this will be the bracket, minus 120,000 minus, here is 125. And 25,000 all over 40,000. Right. So we will be getting 0.88 here. And we will be also getting negative 0.88. 1 3. It will be negative 0.12 something, but when you run it, you will get negative 0.13. So we will trace 0.88 on the calculator. 0.88. 81069 we also get 0.44. Then now we'll be getting 0. Is it fine? Is anybody missing?
No, sir.
No, we are not missing. But
Okay.
you see that the ones that I sent you, I didn't run them, so I'm getting different figures. Not really. The difference is not.
I was marking it correctly because they were close.
So next time I'll do it like that.
Yeah, that's different.
I'll do it like this. I mean.
That's every day.
Thank
Yeah.
you.
Yes. You're welcome. So let's quickly move on to today's topic. Someone is saying say is lost. You are lost. How can you be lost?
It's also a GPS near finding it near to us.
Nah, the way they are young.
Let's solve one last one. That one you didn't give it to us as an assignment. The one before the sampling distribution. That question before the sampling distribution.
Okay, I'm fine.
Hello.
Yeah. Me back question I'm reading to my ID. For the first part there easy, but the second side number. For the first part there, what what we will do is we are going to subtract 40,000 from this over this. So the answer that we will go and get on the Z table, we take it out of 1 because to last more than 40 miles, so it means that greater than 40 miles. So that one we subtract 1 from it. We subtract it from 1. But here for the second one, I don't understand. Assume that. Can anyone help us? Country size expansion. Until that will provide a discount on does anyone understand the second part?
Yeah, we are trying to read and make meaning out of it.
Sure, coffee.
Yeah.
Yeah, don't you think maybe we are going to maintain the mean and the standard deviation? Then the question actually starts from what should the guarantee mileage be if the company wants no more than 10% of the ties. So why don't we find 10% of the ties? Then the answer we get becomes the new question itself.
So does it mean that 10% of the uh,
So 10% of the I think wait oh, I think it will be 10% of the mean, as in the 36,500 or so.
okay.
Yeah, that's my understanding of it. Because when you look at it, it is saying that assume the Hankook tie is considering a guarantee that will provide a discount on replacement ties if the original ties do not provide the guarantee mileage. Now, what should the guarantee mileage be if the company wants no more than 10% of the ties to be eligible for the discount guarantee? So this time around, the question itself is no more than 10% of the ties. So
Yeah.
P is equal to X, and no more than means less than or equal to 10% of the.
Yeah.
So looking at it, I think that you will find the 10% of the 36,500 because that's the one that represents the type over there.
Oh, okay.
Yeah.
Okay. Then I'll count. We have so a bit wasted time. We are no what solve it. What are two group?
Math.
Means me
Math.
try.
Okay.
But the first side, yeah, Rejoice, you can solve the first side, right? Rejoice,
Okay. Hear me?
I hope you can solve for the first side, right?
Yes, I can.
Mm-hmm.
Can you hear
Second
me?
side. Yeah, I can hear you now.
Okay.
Okay, so let's go to today's topic. We've used 30 minutes already. Let's go to today's topic. Today's topic is sampling distribution. So basically, it's about samples. This topic, and I make as I spent billions. Okay, I just say where and I spend plenty. I got confused because the lecture can be put the numbers and the book class and so forth. Lecture the room free class now on 3, and I became away from the class as 3 that.
Let's try the whole point being a master now. Say class me.
So at the end of this session, you should be able to understand the importance of her voice. Judge me. You should understand the importance of sampling distribution, sampling error, describing whatever for normal population using the central theorem, central limit theorem, and then earlier say examination final timetable has been posted. Yen train on be take it. Any else now?
Until okay, I was like,
I'm saying examination. No, final timetable is out.
Okay.
All right, so now let's start. So starting from a population. A population is the set of all items or individual of an interest. So a population is what the main focus or whatever we'll be doing will be targeting. But just that we'll be picking samples from that population to assume how the population will behave. So population can be all likely voters in the next year election. all parts produced today, all sales received for November, all students in the University of Ghana will be the population. And the samples is when we are selecting some of the population. So if you are selecting only 1,000 voters out of all the voters, will be the samples. And then if you are selecting a few parts of destructive testing, like let's say cars brain accident, but we are selecting some parts there. And if let's say we are also selecting every 100 receipts for an audit, so maybe the company will have like 1,000 receipts. So we are selecting every 100th one, every 100th one. So basically that's what means. So in this case here we have A, B, C, D up to Z. So if we select some of the alphabets within A, B, C, D up to Z, that will become the sample. So A, B, C, D up to Z, we selected B, C, D, I. So we selected a sample of them. That's what it means here. So why samples? Why are we using samples and those? So using samples is less time consuming the whole population, and it also costs less to administer than the whole population. And then if testing is destructive, that is in a situation where complete enumeration is impractical. For example, testing for crackers or explosives, crash tests of cars, and testing for eggs. So if we are using samples, it is better than using a whole population when testing those kind of destructive stuff. So it also helps minimize error from boredom due to large numbers. So if the population is very large, then we need better. So as far as we need better, one is obeying mistakes. That's what it means here. So it is possible to obtain statistical results of a sufficiently high precision. So when I say you will get high results based on the samples that you take. So sampling technique, we have the non-probability one. That's when you judge or what is available at your convenience. And the ones that we'll be doing today is either simple random, the probability sample, sorry. So the probability samples have simple random, stratified, systematic, and cluster. This probability types were treated in either business maths or business statistics if you were in diploma. But if you were in degree, it was business maths. So key definition here again. But it again, a population is the entire collection under the Constitution. So all voters, all UGBS students, all receipts, and those kind of stuff. So the parameter is just a summary that measure the summary measure computed to describe the so whatever will the characteristics that will assume for the population is the parameter. So the same here too is the sample. Sample is the portion of the population that has been selected. So a statistic is a summary measure computed to describe the characteristics of the sample. The same thing here. So for making so in inferential statistics, sorry. So making statements about population. So inferential statistics basically mean that we are using the sample population, the sample that we selected to assume for the whole population. So let's say in this class, this class that we are having right now, we have 5 people here right now. So if I pick 2 as a sample and I ask them that, have you understand? And they tell me, say yes. Then I assume for the whole class that everybody has understood. That's what the in reference and the inferential means. That's what it means here. So making statements about a population by examining the sample results. So sample statistics here, we will make our results to assume for the whole population because we don't know. Maybe one of you guys don't understand what I'm teaching. But since I've asked 2 pairs and I've assumed that all of us understood. So here, the population parameters are unknown, but can be estimated from the sample evidence. So the 2 that I selected will be my sample evidence here. So that's basically what I. That's why the lecturer will teach, and then he will say that if only one person understood whatever he taught, he's okay. The sample here one out of the whole class. The sample here one. So when you study something. So the same thing. So inferential statistics is the drawing of conclusion or making decision concerning the population based on the sample result. So, for example, if you're estimating the mean weight using the sample mean, if we select some few um, samples and then we check their mean, we assume that the whole population has the same weight, like it has that weight. Sorry. So hypothesis testing also have the same. So using sample evidence to test claim that the population mean weight is 120 pounds. So we will select some few of the population. We look for their mean, and then we assume that the mean of the whole population is that one. So this will lead us to something we call sampling error. So if you want to test for sampling error, it's simply the sample mean minus the population mean. So that's the sampling error. It's simple. So sampling statistics are used to estimate population parameters. Example, this is the mean. It's an estimate of the population mean. So the sample mean is the estimation of the population mean. So basically, that's all. So the sample results have potential variability that sampling error exists. So population, this is the formula for population mean, right? Population mean, right? Almost your class in but let me break this down for you. So what this Nyama basically means is the whole population, like the whole population, addition of all the population. All over the number of the population. So if you were adding them and then they are 10, right? The number of them they are 10. So if population, let's say if you are dealing with weight, it be a 32, it be a 40, it be a then, and they are 10. So you add all of them, then you divide it by 10, and you get your population mean. So no no my no say what right? So basically that is it. Please, are you okay with it? Are you okay with it? Is anyone confused?
Yes.
All right.
But don't clean it, wait.
Oh.
Oh.
I'm coming.
Hey, James, we all said oh together.
Okay.
I brought it back.
Okay, thank you. I'm done.
All right. So I've been with Jimmy. Hey, sorry. So this for the this is what the population means. So the same way here, this sample means the same way here. So you add all the samples that they've selected. So addition of all the samples that they've selected. Addition of all the samples. Uh-oh. So addition of, so when I'm representing by this, so addition of all the samples all over the number of the samples selected. So basically, it's still the same thing. So first, we add all the population and divide it by the number of them. And then the sample mean to the same thing. We add all the samples and divide it by the number of samples. Does this look difficult? If you are basing on this, there will be plenty for your eye stop. But this and this is what I've broken them down. Thank you for understanding. Can I clean it?
Yeah, we can clean it.
All right. So we'll move on. So that's it. So according to the formula here, this U is the population mean, this is the sample mean, and Xi is the values in the population. So the values in the population, which is as I made an example of maybe 30, if it is with 30, 40, 22, and those kind of stuff. So you add all of them and then divided by the population side. If it comes to the population, you divide by the total population. If it comes to the sample side, you divide it by the sample, the number of samples. So basically that's it. But just that when you see this, it's not yeah. So look at this example. So this example here of a population and a sample mean here. So what they did is, if we want to look for the population mean, they added all of this, right? All the population. So we are calculating the population. The table below is a list of number of projects and are taken by company X and associated project sizes. So square feet. So they added this square feet to this one, or they added all the square feet, right? And they had a total of this. And the number of this thing they took was 1. The total population was 1, 2, 3, up to 12. So they divided it by what? 12. You see? So they divided it by 12, and they had what the population mean. So look at the sample mean. Sample mean here, they selected a few of them. They selected this one. They selected this one. They selected this one. They selected. So they selected only 5 samples, right? So when they selected the 5 samples, they added them and then they divided it by what? The 5, right? And then so the total will be this divided by the 5, and then they had this. So this is where the sampling error comes in. Before we will come here, I made mention that sampling error is what? The sample mean minus the population mean. So let's continue then. So sampling error. Sampling error is the difference between the population and the difference between the sample mean and then the population mean. That's basically what it means, and they've place it in this plain English here. So let's move on. So where X bar is sampling mean and the U is the population mean. So from the above, when we subtract this was the sample mean, right? And this was the population mean. So this will be our sampling error when we subtract this one. When we subtract it. So basically that's it. So please, up to this point, is there any confusion? Was that a mathematics challenge selection? Is there any confusion? And everything is fine?
No, we're not confused. Fine.
Everything is fine.
All right. So as they are saying here, if the population mean is also, for example, they've also given us a population mean of 99.5, and a sample of 5, which is also yielding 99.2. So when we subtract the population mean from the sample mean, we are getting negative 0.3 here. So that will be our sample error. So these are all. So if we are also to, the population has a mean of 125 and a random of 8. So this thing too, you can add all of them here. So the above will be equal to, let me add all of them. Let me add it and see. 103 plus 123 plus 99 plus 107 plus 121 plus 100 plus. Okay. So I'm getting 852. And it's a sample of 8. 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8. And then I'm getting 106.5. So sample level will be 106.5 minus 125, which will be equal to 18.5. I hope it's understood up to this point, right?
Yeah, we're good.
Yes.
Okay, so I can clean it.
Yes, you can.
So different sample will yield different values from the statistics. Example, mean, standard deviation, those kind of stuff, and therefore different sampling errors. So sampling error may be positive or negative because, for example, the ones that we solved so far, some are positive, some are negative. The expected sampling error decreases as the sample size increases. So that's it. So what they were saying here, different samples will yield different values. So that's it here. So this is the total population value here. And first they selected some few samples. So they selected 1, 5, and then 9 as the sample 1. It has a different mean value here, as you can see. Right? And then they came to for sample 2. And then for sample 2, they also selected 62, they selected 8, they selected 12, and they selected 3. It also has a different mean. So that's what they mean by different samples will have different mean values. So since they have different mean values, whenever you subtract them from the population mean, they will have different sample errors. You understand? So that's what the above was explaining. And then we have the mean of the means. So the mean of the means basically is this plus this plus this plus this. And we selected 4 means right now. So it will be divided by 4. And normally it is closer to the population mean. is closer to the population. So this mean of means is will be take note will be used in ANOVA analysis of variance. So just take note and then keep this in mind that this thing will be used in the analysis of variance when we start treating. Maybe I'm sure that this weekend and then you do one. So please, is anyone confused at this point?
We good.
All right. So one sample say we good in there. Assume say will be okay. But I'm putting whatever we are learning to practice. So sampling distribution. So all right. So sampling distribution is the distribution of possible values of a statistics for a given size sample selected from a population. So it is like the normal distribution. That's all. So for example, since every sample has a mean and a standard deviation, a distribution could be constructed from all the means from all possible samples that could be taken from the population. Likewise, the standard deviation. So the same way that we were for the normal distribution, we constructed the sample mean minus the same thing we can also do here. So so with that, with constructing the sampling distribution, we use something we call the theorem limit, a central limit theorem. So it's we know the theorem here is central limit theorem. It says that if a population is normal, like if a population has a normal distribution with mean and a standard deviation, then the sampling distribution of x, which is the sample mean, is normally distributed with a mean of, which is this is the population mean. This is the population mean, and the standard deviation is so called the standard error, which is here. So therefore, the z value for the sampling distribution of the sample mean becomes this. So basically, I told you earlier that what we did in the previous chapter was what? A stepping stone to the next one. So if you remember, the previous one was the mean, the sample mean minus the population mean all over standard deviation. But here they've added the root of the number of space, like the number of sample space. They've added the number of sample space to this. I'm coming. Give me some few minutes. All right. Sorry for the inconvenience. I am back. Open. Okay. Sorry, put it at little bit here. So this is the same formula here. Yes, same formula here. That's we were using. Now they've just added root. So as time goes on, you see they'll add some again. The next chapter they'll add some again. Moving on, they'll add some. That's basically what. So whatever you'll be learning in the previous chapter is a stepping stone for the next one. So and then bubble. So basically that's it. So as you know, this is the sample mean, n is the sample size, this is the population mean, and then this is the standard deviation. So basically that. So sampling distribution. What if the population is not normal? So it means that what if the population is not normally distributed, right? If the population is not normally distributed, we can apply the central limit theorem, which says even if the population is not normal, sample means from the population will be approximately normal as long as the sample size is large enough and the sampling distribution will have a mean of this is the population mean and the standard are the same thing. So this what is so as this is central limit as the sample size gets large enough, the sampling distribution become almost normal. Same thing. So how large is large enough? For most distribution, n is greater than 30, meaning the sample size is greater than 30 will give a sampling distribution that is nearly normal. For fairly symmetric distribution, n is greater than 15. For normal population distribution, the sampling distribution of the mean is always normally distributed. So, for example, they give us this example here. Suppose a population has a mean of 8 and a standard deviation of this 3. Suppose a random sample size of 36. What's the probability that sample mean is between 7.8 and then 8.2? Let's quickly solve this. It's not difficult. Legonde so mama figures we say the nine day anything. They share a passage mu we read be long is answer. Na ya asem. So here mean population mean is equal to 6, and then standard deviation is equal to 3, and then the number of samples is equal to 36. We should find probability that I think it's on 7.8. Oh, I hope you can see my whiteboard.
Yeah, it's visible.
Okay. So I always will solve for this one first. So 8.2 minus the mean. All over standard deviation square. Maybe There is the formula as we know already. Right, simple and straightforward. So we'll punch this on the calculator and then so we'll locate these two, this and this on the Z table. So let me locate them.
Yeah, Kofi.
Yeah,
I was it 0.4 now.
yeah,
But it was G tables, right?
yes.
Is it
Negative
the Z
the
tables?
Z table. Yeah, the Z tables. Or you can use the calculator. Abi, you know how to use the calculator today.
Yeah. I know it's a calculator. But my calculator didn't be because a bossy calculator be no me who we
Oh, should I?
because come here there.
Okay. So this will be our ability. So let's say yeah. Right. Maybe I'm a drop off this. I have some mean here is population mean here is and then you're looking for between here 7.8 and then here 8.2. Probability between this inside here and 0. Is there anyone who don't understand?
Hey, you have to draw in now.
We're in the mama too.
Drawing. Hey, Demi, I don't know.
It's not the beer me
Drawing.
no.
What is drawing?
The
The bell
beer. It's not the beer me no. The beer won't say the beer me yeah. Draw them. Draw shape no. They me draw tortoise. But I find this
But wait, is it 70.31 this one? Where from that one? I don't understand.
Where from where?
Is it 70.3108?
70.3108. No,
After
I'm just
drawing it, the arrow that
it's an arrow. It's 0.3108. I'm just showing say this the probability of this the thing within this zone will be this one.
See,
okay.
Yeah.
the drawing the
What
bell
what
shape,
you
no?
shaded this from?
Are we using the free hand? Are we using our free hand, or you are drawing to a scale?
Oh, normally freehand. Want to mean you
Freehand.
skill I didn't know.
But
Because
what you shaded
only
to
the
other
horizontal
side?
one.
Eh?
Or say what have you with the shaded portion? He's trying to shade within the points given. That's within the 7.8 and 8.2.
That's the within. Yeah.
Okay.
So are you fine now?
Yes. I think so.
Me too, I'm okay.
All right. Pacho, Obi, are you okay? Obi, are you okay?
Okay.
So I can clean it.
Yeah, clean it.
Okay. Rejoice, can I clean?
Yes, I'm taking a screenshot.
All right.
Kofi, are you talking?
Sorry. I'm meeting. So I think that even if the population is not normally sharing here, since it is not stated explicitly, the central theorem can be used. So that's what they've used here. So what we did, the same thing, Maya was asking.
Yeah, please, I have a question, okay?
Okay.
So because the n, which is the number greater than 30, right?
Yeah.
That is why we use this formula, the central theorem, right?
Yeah.
So assume it was, let's say, 29 below, we will use the other formula, isn't it?
Yeah. If it was 21 and below,
21 and below,
29 and below, that one it is not treated on this this page. It will be treated on another page. Like I said, no different session.
Okay, I get it. I get it. All right. Thank you.
Okay, so for example, even by one is even here. Suppose that the population is known to be normally distributed. Okay, since they've already told us, even though said the n is 8, but they've given us that it is normally distributed, so we are still using the normally distributed central theorem. Since they told us, but if Nanka they've not told us there, I think that one will be treated in another way. So this one is the same thing. So calculate the probability that the sample will exceed, will be greater than. So since it is greater than, always we subtract it, the probability we will get from 1. So that's what they did here. Yeah.
Yeah, you watch the slides now. Apart from the n is greater than 30, they brought another one which is n is greater than 15. With
Yeah,
that
yeah,
one, they
yeah.
said it's fairly normal. So it
Yeah,
seems
fairly no.
even if it's lower, you still use the distribution as in the normal distribution formula.
Yeah,
But
since
just this
it
time
is still
around,
within.
you still use that same formula.
Okay, thank you. I also come one. Hey.
That
Otu
you
trotro.
say more airport play me never find me too na.
Or otu trotro.
Ubenaka.
So basically, they did the same thing here. Same thing. Yes. So to consider a normal distribution with mean of 12 and a standard deviation of wait. So this here, what we are going to do is solve for the 36 is now constant. So we are going to change the n by 1 for the first one, n 16 for the second one, then n 25. So it's just the same thing as what we did. It's the same thing. So here comes this example. The branch manager for United Savings and Loan in Seaside, Virginia, there or Ghana, so Virginia has worked with her employees in an effort to reduce the waiting time for customers at the bank. Recently, she and the team concluded that average waiting time is now down to 3.5 minutes, with a standard deviation equal to 1 minute. However, before making a statement at managers meeting, this branch manager wanted to double check that the process was worked as thought to make this check. She randomly sampled 25 customers and recorded the time they had to wait. She discovered that the mean wait time for this sample of customers was 4.2 minutes. So initially, we think of where the average waiting time is. And now she also got this. So based on the team's claims about waiting time, what's the probability that a sample mean of 25 would be as large or larger than 4.2 minutes? What should the manager conclude based on this data? So what they are trying to do is you need to this is the old population mean as that um, the people and I say the people working with the woman has gotten. So and then now there's a new sample mean. So what we are going to do is the sample mean minus the population mean all over this one, which is the standard deviation and the root of 25. So basically that's what is happening here. So we know the already population mean the work rate is 35 minutes. Standard deviation is 1 minute. The sample mean now is 4.2 minutes. And then the number of person is 25. So the same thing, 42, 4.2. Since we are looking for the probability of as large or larger than, so meaning that greater than. So everything which is greater than BR, we are going to subtract it from 1. So as it's also shown here, 4.2 minus 0.5, 1 over 1 divided by the root of 25. So we will get 0.75 times 5. It's the same as 0.75 0.7 sorry divided by 1 over 5. So when you put the same thing on the calculator, you get the same thing. So 4.2 minus 3.5 all over 1 Then the root of 25 is 5. So that's why they've gotten. So if you remember the division, if it's 1 over 5 and you are dividing, you interchange it and then you multiply. So that's the same thing. That's the same thing. So they had a probability of this thing was 3.5. So 1 minus 3.5. Check the 0.5 on the table. I'm going to do that very soon. Okay, we had 0.99977, which is almost 1. And then the first one that they tested was 4.2, so 4.2. So also the same thing. So they are almost the same. So that's why the interpretation, it is almost surely that the sample mean cannot be larger than 4.2 minutes. There could be some credibility to the team's claim by the manager, and perhaps take another sample, so whatever. Like whatever happened there, do you guys understand and answer? We should solve it and kasa differently. Because what they solved here and then me breaking it down.
Please let's solve it and kasa for better understand.
Right.
Please, are you talking?
I don't know if you me mute me. I say for better understanding. So according to the passage, they've given us a population mean of 35, 3.5, sorry. Standard deviation of 1. And then a sample mean of, and then the number that was selected was 25. Right. So if we go deep down, and we know it is normally 4.2 mL. Oh,
Sophia, are you
We get it.
talking?
I wasn't talking. I was just solving it. So we know the formula was the sample mean minus the population mean all over the standard deviation and then the root of the number of samples. So that's what I've done here. So 4.2 minus 3.5 all over 1, then divided by the root of 25. So we will get 0.7 at the top here, and then down here we will get 1 over 5. So when we plug them on the calculator, we are going to get 0.5. So now we are going to plot this 0.5 on the Z table. The Z table. So plotting it on the Z table will be 0.5. We are getting 0.99977, which when we run it, it is approximately 1. Oh, and then when we use the old Z table, the old when the workers checked, they also said the thing was 4.2, right? So we can also plug that 4.22 on the Z table, and then we are also getting 0.99999, which is also approximately 1. So when we compare them, we can see that there's no much difference like that. There's no much difference. So when we compare them, we can say there's no much difference. So we can conclude that according to the sample that was taken, whatever was calculated by the workers is almost correct. You understand? But maybe that's what they are saying. So maybe you should take another sample and check, because maybe he took a sample that will be favorable. Maybe when he takes another sample, maybe it will be different. So basically, this was what was done there.
Kofi?
Yeah.
Yeah, we didn't subtract. We are supposed to subtract it
Yeah,
from 1.
yeah, we didn't subtract. Yeah, but this is I was working based on the assumption that they are asking. So we can either use it this way because we are comparing. We can either use it this way, and also we can also subtract 1 from both of them. So we can subtract 1 from this one, like this one, right? And then also 1, we can also subtract this one from 1, and we will arrive at the same thing. It's because of I want a faster time. So since it's comparison there, we can just compare the answers. It is not always say we will subtract 1 from it. We are just comparing, say whether what the workers are saying is true to the sample that the madam has also collected. So if we are able to compare the two and interpret it, it is also like the same thing. Please, have you taken a screenshot already?
Yeah, so.
All right.
But what -1 is he talking about?
Because they are telling you that, see the question, they are telling you that, if I'm the question. See, they are telling you that, they are telling us that people, they are telling us for the number of samples, people, 25 people. Okay. Based on the thing about waiting time, what is the probability that a sample mean for 25 people would be as large or larger than, so greater than or equal to? You get it? So after that, greater than or equal to be, you take 8 out of 1.
Yeah.
So that's what it means. So let's continue. Can do with the HACCP, population proportions. HACCP non-FS with safety problem. I did win any homes in a bomb. So population proportions. So the same as we have the sample mean and the population mean, the same thing we also have population proportions. So in the population proportions, the population proportion is the same as the infant example. That's like the way sample mean is you add all the samples and then you divide it by the number of samples selected. The same thing, the population proportion to you add all the sizes and then you divide it by the number of sizes. You understand? So just as the sample mean provides a summary measure of the population values, sample proportion can also be used to provide a summary measure regarding the population when the emphasis on a percent of population when the emphasis is on the percentage of population. So if P is equal to the proportion of population having some characteristics, then the sample proportion will be P bar. So P bar provide an estimate of P. So the same thing they are telling us here. So P bar, which is the number of success or no, divided by the number of sample sizes. So maybe they can tell you say in our class there are, let's say in our class they can say that maybe 10%, 10%, whereas 30% are girls. Like in quantity class, the infants 30%, even though the man who doesn't say men. So maybe they are saying 30% are girls, right? And then now they've selected a sample of try duration. So maybe they are telling us that 30% are girls, right? And then now they've selected a sample of, let's say, they've selected a sample of, let's say, 40, right? And then then they're asking us that what is the probability that 15 are girls. So if they're asking us that what's the probability that 15 are girls, if we want to get the population proportion, it will be 40A. It will be the number of success, which is 15 that we are looking for as girls, divided by 15 divided by, so let me bring the equals. So this is how it's 15 divided by 40. So the P bar for this, and I said the population proportion for here will be 0.375, right? And this is the probability of success, which is the P. So you go deep down and you understand it better. Just that the slide they didn't really explain it far better, but I'm breaking the population proportion down here for you. Please, did you see the Excel screen? Did you see it?
That's what you are seeing right now.
Now that you are seeing it.
No. Long time. We ain't forget it.
Okay.
Sorry.
Okay. So let me continue. So the same thing is here. So sampling distribution, like the same normal distribution type. So they are telling us that if the number of samples selected times the probability of success is greater than 5, then we assume that the distance is normally distributed. And if the number of samples is also the number of samples multiplied by the probability of failure is also greater than 5, then we assume that the sample distribution is normal. So the same thing. So the mean here is the population proportion. and then the standard deviation is denoted by this formula. So root of the probability of success times the probability of failure. Do you remember probability of success and probability of failure? So if let's say you have probability of success, if our probability of success to be maybe 0.2, and then if probability of failure it will be 1 minus this one, and get probability of failure. I beg someone was talking. I beg someone was talking.
No, you asked if you remember the probability of failure and success.
Okay, okay.
We have it, so.
Okay. So basically, this is the same thing here. So we'll get a question and then. So standardized P. So the P, which is the proportion P. So normally this is the formula for solving for the Z value when we are dealing with proportions, right? So this is it too. This is basically when you break it down, there's this. So normally, whenever a question is given, I want you to first solve for the standard deviation first. Then whatever you get, then that one will be faster than you doing them one by one. Normally, the standard deviation is given for all of them. Sometimes if it will be changed, for example, a few questions will be. So here, the P proportion, population proportion, minus the probability of success. So always population proportion minus the probability of success. Same thing. Please, who remembers the what I just did for what I just did for the population proportion? Who remember?
The one you
said the
okay.
Which one? The population proportion is it not the one that you were like the is it the population is it the sample mean? Sorry, the number of success over the sample size.
Mm-hmm. So yeah, not over the over the sample size. So I don't know.
So number of success over the sample size.
So when I say let's say they take the population of let's say our class and then they take probability of they take a sample size of let's say 40 and they tell us that what is the probability and what let's say what is the probability that they will be selecting 15 or probability that 15 of the 40 will become ladies. So let's say total the sample size is let's say 40, right? And then girls is equal to 15, right? If you want to find the P proportion to be equal to 15, which is the girl that we are looking for all over the total, is the 40. So basically, this is how the P proportion is computed. So if your question is given, so let's go down and see. So here they've given you something simple. So if a true proportion of voters who support proposition A is 0.4, meaning the probability of success, what is the probability that the sample size of 200 yields a sample proportion between 0.4 and 0.5? So what you are going to do is, first of all, you solve for the standard deviation, which I always say. Then normally do that one first. Hey, is my audio back? Is my audio back?
Yeah, it's on.
Okay. So with this example, we will first solve for let's first solve for the standard deviation. So the standard deviation is equal to root of probability of success and Q. Root of failure all over n. And then yes, sir. Yes, sir. Hey, board now fine. Oh. Mhm. So here this thing was root of probability of success was 0.4. So probability of failure will be 0.6 all over 200. So we are getting
Marco.
was it then?
I'm about to
Mm. So basically this is the standard deviation. So now they are telling us what is the probability that this will be between 0.45 and 0.4.
A question, quick one.
Okay,
So,
quick
like,
one.
the probability, the constant figure for probability of success is 0.2, right?
It's what?
0.2.
0.2. Where?
I don't know. I'm
No.
asking.
Probability of success will be normally given in the question. Sometimes they can give you probability of success, a failure, and then you solve for the probability of success. So you know that always probability is equal to 1, right?
It's better one. It's better one.
Uh-huh. That's probability.
Sorry.
That's the whole probability, not only success. The whole probability is equal to 1.
One.
Mhm.
So if probability of not a failure would be 1 minus 1,
Yeah, 1 minus the probability of success.
in case they don't do this one.
Yeah,
Thank you. Bye bye.
you're welcome. So bye-bye. So now let's solve for the distance between. So it was T 0.4 and then so always I say we'll solve the first one, this one first. So P proportion minus P. It has a P proportion, sorry. So Are we lost, and you understand what I've done so far? Please, is anyone lost? And I say we all understand what I've done so far. So I'm going to trace the listing on the table. Is anyone missing? Are we okay up to this point?
Yep.
Okay, so since we are all okay, then I think that this one, so we would draw our sources. And then the population mean was population proportion was 4. And we are checking between the 4 and then 0.45. So be from here. Mhm. Screenshot.
Hello. Hello.
Yeah.
So the final answer was
Yeah. Hi.
0.4265, right?
4 2. Yeah.
65. So I suppose
Yeah.
let me use the word plots on the bell shape, isn't it?
Yes.
Okay, so the region that you shaded represents the 0.4265.
Yeah. It represents between 0.4. You see, in the question they ask us 4 is this thing that it will be between 0.4 and then 0.45. So 0.4 here, and then 0.45. Sorry, my first zero number. 0.4, 0.4, and then 0.45. So that's the area that I've shaded here.
Okay, I get it. Thank you.
You're welcome. Is that okay now?
Yeah.
Okay.
Well, Rebecca.
It's in the Ubu Germany now. Bet, bet. Um, so in the slide, they made a mistake here. According to the standard deviation, they made a mistake. It should be 0.0364, like 0.0, but they made a mistake. It's like you can try using a calculator. You see that they made a mistake here. So because they came and arrived at the same thing.
Oh, the lecturer is out. Come again?
I said you said it was try. You said it was funny.
Sorry, my network table. I've been before big. Please, is everyone seeing my screen again? Hello, is everyone seeing my screen?
Hello, sir.
Hello.
Yes, still here.
Are you seeing my screen?
Oh, we can hear you.
Okay. Sorry for
Your screen.
sorry for the inconvenience.
Don't worry.
All right. So, okay. So, as I was saying, here there was a slight mistake. There was a slight mistake. So if in case you're going through the slide, pay attention to that side. And that's why normally I like solving like solving it, what they've solved in this slide, just for me to compare the thing. Mm. So look at Legon. Look at Legon. Look. Oh, Moon.
What's today?
They are the same.
Give me
Hey.
break you.
Wow.
If you only me or
example, somebody a survey, you know, is breaking.
The example we
Is it
saw,
final?
we are right at 0.4265. Hello?
And then they arrive at 0. Okay. Yeah. Hello. Are you hearing me?
Yeah, we can hear you.
Yeah. You were saying something, right?
I was saying that the question we solved, okay, he arrived at 0.4265, and you were saying there was a mistake. I'm sure the mistake is what rendered a difference.
Yeah. Okay. Okay. 4. Okay. And then moreover to uh, for the last two numbers, what we're doing, I rounded it to the nearest. We had 1 point. We had this. We had this 1.445 something. So if you have to run it to the two decimal places, it will be 1.45. That's why we had 1.45, and then they had 1.44. Are we clear? So let's quickly solve this. Then I give then I give this as an assignment. So first on the second one, according to because of this question, I have solved it. So when I was teaching, I made exam select one student, and then because I've solved this class. So according to the most sense of yes of engineers, which are mechanical, civil, and industrial women, suppose a random sample of 50 is selected.
distance lecture is coming stop.
Yeah.
Distance lecture. One day,
The TA is computer success. Now made it here.
I beg, I no be here. I beg you.
This life, I prioritize only two things.
Yeah, take
This
over.
thing and that thing. Computer success.
Success, please.
He's a quiz boy. Quiz boy for work.
Quiz boy.
Quiz boy for Chroma.
Which boy picture like that?
I can't tell answer. Which boy picture?
Hello, I'm back. I'm back. Can you guys hear me?
Yes,
Yeah,
I
I
can.
can
Yes,
hear
yes,
you.
we can hear you.
And you may wait there. I'm person in bed in the year cry. Oh, what is happening there, me pa? It been too me say, brother. Hmm? So we are back again. We are back again. So according to okay, you are saying how likely is it that the population, the random sample of 50 will contain 8 or more women in these positions? How likely is it that the random sample will contain fewer than 5 women in this position? And then if the random sample included 200 engineers, how would this change your answer in fact? So basically, the probability of success here is what? 0.105. I hope you remember, right? So let's quickly read it. Let's quickly solve this. Please, I hope my line is not breaking.
No, it's not breaking.
Okay. So now, probability of success is equals 0.105, which is the same as the 10.5%. It's the same thing. So population proportion here will be equal to 8 over, because we are selecting 8 females, so 8 over 50, 8 over 50. It will give us 8 over 50, 0.16. And then let's solve the standard deviations. Standard deviation to be equal to probability of success, which is 0.105 times probability of failure. Probability of failure will be 1, so 1 minus 0.105 will give us 0.895. All over the total number of the sample selected is 50. So we are getting 0 point it would have been 0.4335, but when we run it, it will be like this. So there is a standard deviation, there is a population proportion, and there is a probability of success. So now we can solve this here. So we know the formula is equal to P bar minus P all over the standard deviation. So P bar is 0.16 minus 0.105 all over 0.04. We are getting 1.27. 1.266 something, so I've rounded it to 1.27. So now we trace this on the Z table. On the Z table, will be 0.89. This is the A aspect of the question. Let's check the B. So how is it that the random sample will contain no more than
Kofi.
yeah.
Yeah, it says 8 or more. So you subtract from 1.
Yeah, or
The
more.
question
Hey,
says,
me, 8 or more. Sorry. 8 or more means greater. Sorry. So it will be 1 minus that probability. So 1 minus. So 1 minus 0.89. Equal to so this is for the A. Let me go and check the B. The B aspect is how likely is it that the random sample will continue? It will contain fewer than 5 in this position. So fewer than 5. Fewer than 5 will have a different population proportion. So now, what is the board? So fewer than 5 will have a different population proportion. So now fewer than 5, 5 divided by 50. We bar now with 5. And to give us 0.1. So now we are now coming to the 1 minus 0.1 minus 0.105. All over the standard deviation will be 0.047, which will be equal to 0.12. So if you trace it on the Z table, negative 0.12 will be 0. Everyone said this equal to Z. That is equal to Z. Z. So now it will be 0.4522 on the Z table. So this is the probability for the D aspect. So now let's look at C. C is saying that if the random sample included 200 engineers, so now they've added 200 engineers. So since they've added 200 engineers, then now the number of this thing will be 250. So now n will become 250. So you have to solve for the standard deviation again. You have to solve for the standard deviation again, and then now p proportion to change. P bar will also change. So now P bar will be P bar will be equal to 5 over 200. Sorry, 5 divided by 200. 0.025. So this will be our new P bar. And then now standard deviation will also change. So now it will be standard deviation will now be equal to root of 0.105, which is already the 10% now, times ability of failure will be 0.895 all over. Now the new distance is 200, 250, sorry. And we didn't go as some of passive. We didn't go as some of top. So here instead of 200, it should be 250. And I'm sure the answer will be 0.02. 0.02 here. Okay. So now it will be equal to I baby wrong. Yeah, you. So I'm solving for external deviation and 0.895 all over 250 now. So 0.19. Three, 0.19. 0.01. So, and please, have you guys taken a screenshot of it? I want to clean this side so that I'll come and
Yes,
continue the
I
survey.
have. I'm taking a screenshot. Please, there is. Have you taken screenshot?
For me, I'm writing. No, I'm not taking screenshots. I'm writing, so I'm done.
Okay. So now we already know that it is P bar minus P all over the standard deviation. So P bar now is 0.02. Hey, that's what's the pound. So we are getting negative 4.38. So we face that one on the Z table. It, it's what I'm getting. That's what I'm getting now. So they're asking that. So they're asking that if the random sample included 200 engineers, so if they added 200 in there, how would this change your answer in B? So how it will change my answer in B is that the probability of um, the probability of getting a woman and as a female in engineering is now 0.000001. So it is less likely to get 5 women as compared to what we got in B. So in B, we had a probability of 0.45. But now we are getting a probability of 0.00001. But it is less likely that you will get a lady in that in the inclusion of the 200 distance. So basically, this is it now. So we will do this as an assignment. Okay, it's just similar to what you just did. So it's similar to what you just did. That way. Please, so far, is there anything we don't understand? So far, is there anything we don't understand? Hello? Hello?
Yeah. I'm okay. I don't know for the rest.
Okay. One sample, so you're okay. Cardiac. Are you also okay?
Let's finish the assignment.
No.
You know whether we really understand.
Okay. In place also any assignment online.
Oh no.
All right. So in the absence of, is there any question? Okay. So in the absence of any question, then we end today's class. Thank you very much for joining.
Thank you very much for hosting.
See you all tomorrow.
Sure. Have a good night. Bye.
Okay. Bye.
Bye.